Hello to all, wish you are doing well. In this video, I'm going to teach you the strategy for evaluating integration of sine of x to the power of m times cosine of x to the power of n dx. Now, consider the strategy. First, if the power of cosine is odd, consider that the power of cosine is odd number, like 3, 5, 7, 9, 11. Save one cosine of x factor and use the identity cosine of x squared equal to 1 minus sine of x squared to express the remaining factors in terms of sine. Now, look. The integration of sine of x to the power of m times cosine of x to the power of odd numbers like this, dx is equal to integration of sine of x to the power of m times cosine of x squared, or to the power of even numbers, times 1 cosine of x. Here, we separate cosine of x from here. Now, the integration of sine of x to the power of m times, instead of cosine of x squared, we use the identity of 1 minus sine of x squared, like this, and have the cosine of x dx. Now, by substituting instead of sine of x u, we can easily calculate the integration. Part B, if the power of sine is odd, it means the power of sine here we have odd numbers. In this case, save one sine factor and use the identity is sine of x squared equal to 1 minus cosine of x squared to express the remaining factors in terms of cosine of x. Now look, if the power of cosine of x is odd number, then we save a factor of cosine. And if the power of sine of x is odd number, then we save a factor of sine. Okay? Integration of the sine of x to the power of odd numbers, or 2k plus 1 times cosine of x to the power of n dx is equal to integration of sine of x squared to the power of k times cosine of x to the power of n times sine of x dx. It means we save the sine factor here, and is equal to, instead of sine of x squared, we use the identity of 1 minus cosine of x squared, like this, cosine of x to the power of n times sine of x. Then substitute u equal to cosine of x, then substitute u equal to cosine of x. Note that if the powers of both sine and cosine are odd, or either a or b, can be used. C, if the powers of both sine and cosine are even, use the half angle identities. The half angle identities like this: sine of x squared is equal to 1 over 2 times the bracket of 1 minus cosine of 2x, and cosine of x squared is equal to 1 over 2 times the bracket of 1 plus cosine of 2x. It is sometimes helpful to use the identity sine of x times cosine of x equal to 1 over 2 sine of 2x. Now, look. In an example, we are working an example for this kind of integration that can be exactly here. Okay, now in example 2, find integration of sine of x to the power of 5 times cosine of x to the power of 2 dx. In this example, we have the power of sine, which is odd number. Now, if the power of sine is odd number, then we should save sine of x factor. Now look how we're doing. We could convert cosine of x squared to 1 minus sine of x squared, but we would be left with an expression in terms of sine x with no extra cosine x factor. Instead, we separate a single sine factor and rewrite the remaining sine x to the power 4 factor in terms of cosine x. Now look, sine of x to the power 5 times cosine of x to the power 2 is equal to sine of x squared and again squared times cosine of x squared times sine of x. Here, we separated one sine x from sine of x to the power 5. Okay, and is equal to 1 minus cosine of x squared. Instead of sine of x squared, we use the identity 1 minus cosine of x squared, and times cosine of x squared times sine of x. Now, substituting u equal to cosine of x, we have the u equal to minus sine of x dx, and so integration of sine of x to the power 5 cosine of x to the x squared dx is equal to integration of sine of x squared, again squared, times cosine of x squared times sine of x dx. And now, instead of sine of x squared, use the identity 1 minus cosine of x squared, and the remaining is the same. Now, putting the substitution here, 1 minus u squared, again squared, times u squared times minus du is equal to minus integration of u squared minus 2u to the power 4 plus u to the power of 6. Now, this kind of integration, which is algebraic, is very easy. So the integration of this form is like this, plus a constant c. And again, we use, instead of u, its substitution, which was cosine of x. The final answer for this example is minus 1 over 3 cosine of x cubed plus 2 over 5 cosine of x to the power 5 minus 1 over 7 cosine of x to the power 7 and plus a constant. Okay, that's all. If you guys have suggestions that which subject we should focus further, you can mention in a comment. That's all.